you just go to Friday too? What? It's you? No. Hey, dude, let me get pulled up. Oh, yeah. Only Sunday on
Right. There were several questions, like number 1, where it asked you about if they were one-to-one functions or not. You're checking x's and y's in that case. Nothing can be shared. X's, I got a -3, a -2, a -1/3, and a -9. That's all good. Nothing is used more than once. Y's, I've got a half, a -3, a 2, and a 3/8. That's good. Nothing's used more than once. So it is going to be one-to-one, so you can mark C out. Once you've decided it's one-to-one, all you got to do is write the inverse, which just flips the ordered pair. So we originally said -3, 1/2. You're going to write 1/2 -3. Where it said -2, -3, you're going to flip that to -3, -2. So you just need to go through there and flip them all. Okay, everybody good on that? All right, number 2, we got log base 9 of x minus 3 plus log base 9 of x minus 3 is equal to 1. Now, this one I've told y'all all along, when you're solving and it's in log form, you want to rewrite an exponential. When it's in exponential form, you want to rewrite it in log form. This one's in log, but before you can rewrite an exponential, you have to get it down to just one log. Right now I got 2 logs on the left side of the equal sign. So what you need to notice is that those 2 logs are separated by an addition sign, and addition is friends with the product property. So you're going to rewrite this using the product property. It'll be log base 9 of x minus 3 times x minus 3 is equal to 1. Now you would FOIL those x minus 3's, so that gets you log base 9 of x squared minus 6x plus 9 when you do the FOIL. Now you've only got 1 log, so you can rewrite that in exponential form. Your n is big, because your n's that whole trinomial, but that's just how it goes. So you got b, which is 9, to the e, which is 1, equals n, which is that whole trinomial. Now you got a quadratic, because that's x squared, so you got to set it equal to 0, so you're going to subtract your 9 away. So that canceled out, just left you with x squared minus 6x equals 0. You could, from there, do the quadratic formula, have an a of 1, a b of -6, and a c of 0. That would work. I just went ahead and took an x out. It's got a GCF of x, so if I factored an x out, it would be x times x minus 6 equals 0. Set both of those equal to 0 and solve. That first one, x equals 0, that's not a choice. So that must mean when you plug it back in, it didn't work. But the other one, x minus 6 equals 0. If you add 6, that gets you x is 6. There were 3 or 4 questions like number 3, where it gives you the equation, tells you what to plug in. You just got to practice pushing it in on your calculator. It's got the number of books in a small library increase according to this function. Books is equal to 6,600 times the number e to the 0.05t power. So B's number of books. T, it tells you, is time in years. How many books will there be after 7 years? So you just got to plug a 7 into the T spot. So you're going to hit 6,600. To get E, you push second L in, and then 0.05. Let me see if it'll erase 0.05. Oh, it erased on mine and not yours. 2 times 7. I'm going to just write it all again. 6,600 times E to the 0.05 times 7 power. Now, it looks like the choices rounded that to the nearest whole book. So round it to the nearest whole book. What'd y'all get?
The
9,366. Good job, Caleb.
Gosh, I'm a genius. I've got them all in my head.
And there's several that are like that. You just need to make sure, if you didn't do it, don't just take Caleb's word for it. Make sure you can type it in your calculator.
You
Good. All right, two more 1-to-1s on 4 and 5. 4, let's see, one of them got to write the inverse. We just got to tell yes or no. So my x's are -16, -12, -6. Check, they're all good. Nothing's repeated. My y's, -10, 14, 9, -9. Nothing's repeated. So yep, that one's 1-to-1. 5, you can plug that in your graphing calculator if you want to. I didn't even do that. I knew it was squared, so it was going to be a parabola. I knew it said y, because f of x is the same as y. It says y equals, so that's an upside down or a normal one, so it's just a normal old parabola. To check a graph, you do the horizontal line test. Horizontal line is going to touch a parabola twice, so that fails the horizontal line test, so it can't be 1-to-1. Six is the one y'all told me gave you an error in the calculator, and it's just all because of those negatives. I'm going to show you how we did it without the calculator. I don't know why the calculator doesn't like those negatives. Okay, that's in log form, so we're going to rewrite that in exponential form. So my base is -2, my e is x, and my n is -8. So like we've been doing on the bell ringers for the last week, I'm going to rewrite those using the same base, which is going to be -2. So that one would stay like it is. -8 is the same as -2 cubed. -2 times -2 times -2 gets you -8. So now your -2's are the same. So that means your exponents have to be the same, and there it's already solved. X is 3. Okay, 7 doesn't have any negatives, so you could just type that straight in the calculator, hit math, scroll it down to log base, and fill in the blanks. It'll work there. I'm going to do it without real quick. Log base 10.
It's log base 10, so you can just press it.
Yeah, you're right. You haven't got to go to math. Good call, Caleb. That's right. Of 0.1, and it doesn't tell me what it's equal to, so that's where I'm going to put my variable. So I would have 10 to the x is equal to 0.1, and 0.1 is the same as 1/10. So I've got 10s, that's good, 10 and 10, but I need to flip 1/10, and to flip it, it takes a negative exponent, but I don't want to change it, so it's going to be a -1. So now my 10s are the same, so it means my exponents are the same. Woohoo! All right, number 8. All 3 properties are used in this expression. I got log base 5 of x to the 8th, y to the 3rd, divided by 7. Remember, multiplication and addition are friends in our properties. Subtraction and division are friends in our properties, and exponents become coefficients in our properties. So I'm just going to start on the top. I got log base 5 of x to the 8th plus log base 5 of y cubed, because they were being multiplied. So I drug it out with the buddy addition. Then I'm dividing by 7, so minus log base 5 of 7. So that took care of the product property and the quotient property, but now I still have exponents that have to come down to the front. So that'll be 8 log base 5 of x plus 3 log base 5 of y, and then can't do anything with that last one, log base 5 of 7. And that's it. Everybody good on page 1? Alright, number 9's another one where they give you the formula. They tell you what to plug in. Just got to be careful on your calculator. Time in years for doubling time is natural log of 2 divided by natural log of 1 plus r. And it says that our rate is 13%. So that means we're going to compute natural log of 2 divided by natural log of 1 plus 0.13, 13%. You can type that in a few different ways. If I were you, I would use the fraction function, hit alpha y equals, and put it in just like that on a fraction. If you want to just do them individually, you got to make sure you hit enter after you do the natural log of 2. So you do natural log of 2, enter, natural log of 1.13, enter, and then divide those two answers. Okay, it rounds this to the nearest whole year. So what y'all practice it? Tell me what whole year it would round to.
6.
Not a kid.
Oh.
6 years. Anybody need help on the calculator? I got it? Alright, the way I did 10, it asks for the domain, and I remembered that domain is what it does on the x and y axis. So I just went and graphed number 10. I hit my y equals button, and then I went down to math and filled in log base 9 of x, and I got a graph that looks similar to that. Okay, so graph that, see if you get something that looks similar to that, and then we'll figure out what that means about the domain. I know it's going to keep going to the right forever, so it's going to keep going to infinity. And I can tell it's going to be 0 here because it's not going to get into the negatives. But the question is B and C. Look at the choices. B has a bracket around the 0 and C has a parentheses.
B.
That's the difference in if it touches 0 or not. So to be sure, with that graph on my calculator, I'm going to hit second table. And I'm going to go to my table and look and see where x is 0 and see if it touches it there or not. Nobody going to try it and see? I'm not going to tell you.
I got C.
What did it, how did you know it didn't touch 0?
I just guessed. I didn't know the table. I just looked at it from the graph.
Well, I didn't say it was right or wrong. I was just curious. It says error there is what you'll see. Good, Rachel, and that means it does not touch it. So Caleb's guess was correct. Just have good parentheses. If it had a value, that would mean it touched it. So then you would put the bracket. Good job. Okay, we did one just like 11 earlier. We know that's a parabola. Does a parabola pass the 1-to-1 horizontal line test? No. Okay, 12 you're going to graph just like I recommended you graph 10. I get kind of nervous about 12 because I think they could make those graphs look close to the same and it'd be hard to tell. But all 4 choices, A, B, C, and D, are very distinct, so it doesn't really trick you very much. So check number 12, see what you get.
I got A.
I did 2. Good job, Sir Plunkett. If you need help on that calculator, let me know. All right, page 3. We got 4 to the x equals 64. 2 different ways we can do this one.
Please excuse interruption. Any junior taking the ACT on Wednesday morning needs to make sure their Chromebook is charged. They bring their Chromebook, their charger, and a calculator, and are there by 8 o'clock a.m. Thank you.
I should not say any junior because all juniors have to do that. They're going to be like, oh, any junior, I don't have to. All right, anyway, on number 13, this is 2 ways to do this. I'm going to do it both with you. The first way, I can make these have the same base like we've been doing the last week in the bell ringers. I can say 4 to the x is equal to 4 cubed. This 4 times 4 times 4 is 64. Now my 4's are the same, so I already know my answer. That's one way you could do it. Other way is you could rewrite it in log form and use your calculator. Log base 4 of 64 is equal to x, and then you would just type that in your calculator and it'd get you the same answer. Okay, 14 you could just type in your calculator, but there's even a faster way than that to do it. It was one of the shortcuts we talked about when we did that lesson when we got log base 1/3 of 1. So if I looked at this in exponential form, 1/3 to the what power equals 1. There's only one power that turns everything to 1.
0.
0, very good. So you could type that in and get it, or you could use common sense and know that it's got to be a 0 to turn it to 1. The team tricked some people this morning. We got log base 8 of 7x plus 8 equals log base 8 of 7x plus 2. They wanted to start using one of those properties, the product or the quotient property. Not going to do that here because the logs are separated by an equal sign. It's only when they got a plus or a minus between them that you use one of those properties. Here we've got log base 8 is the same on the left and the right. So if those are both the same, then that means those quantities have to be equal to each other. So you just set that as 7x plus 8 equals 7x plus 2. Now when you start solving this, you're going to see something fishy real quick. If I go to subtract 7x, it goes away on both sides. So I just have 8 equals 2. Well, I don't know where 8 equals 2 at, but it's not around here. So when you get a false statement like that, it means there's no solution. This is not a choice, and so it couldn't trick you, but what happens if I'd have gotten a true statement, like if it said 8 equals 8? What's that called?
1.
Nope. A false statement's no solution. What's a true statement?
1 solution.
Nope.
Many solutions.
Infinite solutions. You got it. All right, 16, I was worried about that in the calculator, but first period said they didn't have any problem. They typed it in just like it said, and it worked. I did it a little bit different because I was worried about the calculator. So I said, that's log form. I rewrote it in exponential form. So 3 to the x is equal to the square root of 3 to the 6th. That's the same as 3 to the 3rd. Because remember, that's an understood 2 out there in your square root. So you could break that down into 6 divided by 2 makes that 3 to the 3rd. Now that's telling me my answer because the 3's are the same. So my exponents have to be the same. But your calculator could have got that for you also. Seventeen's another one of those formula calculator ones. So it's crazy to me that landfills are this big. Number of acres in a landfill is given by B equals 8,800 times the number E to the negative 0.04 T power. And how many acres will our landfill have after 2 years? So we're just plugging a 2 in. So we're going to do 8,800 times the number E to the negative 0.04 times 2 power. And it looks like it rounded it to the nearest acre.
I got the
8123 is correct. So after just 2 years, that dump is over 8,000 acres big. Oh, 23. Not bad. All right, last page. When we did these like 18 in class, we kind of argued a little bit both ways because we're asked to tell whether that's 1 to 1. So if we start a horizontal line test, well, it only touches it once there, so yes, it's 1 to 1. Only touches it once there, so yes, it's 1 to 1. Only touches it once there, so yes, it's 1 to 1. Some people will argue that when I get down here to where it flattens out, that it's going to touch it more than once. I was trying to change colors. There we go. They say it touches it more than once down there, and it looks like it does on my little drawing there. But if you are to go to one of those graphs in your calculator and look at your table, you see that those Y's are going lower every time. Okay, so even though to our naked eye it looks like it touches the horizontal line more than once, it really does not. So yes, that would be 1 to 1. Those are tricky to look at. Alright, 19, true or false. And I think they're mean to you on 19 because they put the choices as false or true. A lot of people are used to being true and false, and so they'll pick it A, B like that. So be careful and read how they flip those choices up. So you could just type log base 4 of 40 minus log base 4 of 10 in your calculator and see if it gets you 1. If it does, it's true. If it doesn't, it's false. That's one way to do it. Okay, that'll work. I'm going to go ahead and do it using the quotient property because it's got division. This will be the same as log base 4 of 40 divided by 10. And 40 divided by 10 is 4. So log base 4 of 4. Does that equal 1? Well, that's 4 to the first power is equal to 4. Yes, 4 to the first does equal 4. Okay, now this last word problem is a little bit more difficult than all the rest of them because all the rest of them they gave us the T, so we just had to push buttons. On this last one, it's the T we're solving for, so we got a little bit more work to do on it. Says final amount A of T is equal to 800 times the number E to the negative 0.179 times T power. How long will it take a sample of a radioactive substance to decay to half its original amount if it decays according to that function? So we're trying to find out how long. We're trying to solve for T. But what do I put out here in this spot? It said to decay to half of its amount. So what amount did it start at?
Plug in the answers.
You could do, that's right, you could do that. I didn't think of that, but Grace is right. You could go through, plug in 37.34 in the T and see if it got half. 3.87 in the T, you could do that. Correct. But what did it, back to my question, what did its original amount start off at? Where do I find its original amount looking at that equation? No. It'd be 800. Very good, Zane. This number right here is the original amount. So if I'm looking for half of that, I'm going to say 400 equals 800 times the number E to the negative 0.179 T power. Now to start solving this for T, we're going to have to write this in a log equation eventually, but I need to get rid of extra junk first. So I'm going to clear out that 800. I'm going to divide both sides by 800. That gets me 1/2 is equal to E to the negative 0.179 T power. Now there's no more extra junk, that's exponential, so I'm going to rewrite it in log form. So my base is E. Log base E has a special name. What's the same as log base E?
LN natural log?
Natural log, very good, LN natural log. So I'm going to do the LN of 1/2 is equal to negative 0.179 T. Okay, so on your calculator you're going to hit LN of 1/2. That'll be equal to negative 0.179, so whatever you get, then you'll divide it by negative 0.179. So LN of 1/2, enter, divided by negative 0.179, and it rounded these years to the nearest hundredth. What do you got? 3.87 years is correctamundo. Alright, any of that you still don't understand? So much calculator stuff on this, I think this is a pretty easy one.
Done.
That good? Alright, test is tomorrow, so have your stuff ready. Yes, on out.